Hey guys, welcome back. Well, I thought I would share with you some of my findings from an imaging session, first time out imaging session with the William Optics GT81 Model 4, and just let you know what I think of the scope after looking at 6 targets ranging from a couple of galaxies and 4 nebula. We've had a couple of videos out already with the GT81. Started off with the first introduction of the GT81 and some of its features along with my imaging train. I then showed findings of how and when I paired the new telescope with using Nina for the first time out and the autofocus routine, and that all went very well until I pointed it close to the moon, and I put out a video of what happens when you try to shoot narrowband too close to the moon. And whenever you do that, the moon wins and you lose. So now we're going to take a look at some of the images that I actually got from my imaging session with the GT81, both some bad ones and some good ones, I think. Just a reminder of what my imaging setup is. I use a C-GEM, a Celestron C-GEM mount. I have a pole master I use for polar alignment. The legs of the tripod aren't sitting on grass. They're sitting on essentially steel pegs, foot-long steel pegs driven into the ground. So there's a fairly stable platform, and it provides easy relocation of the tripod legs when I have to take the tripod in and take it back out. Of course, the star of the show is the William Optics GT81 that you see here. Its dovetail plate is screwed on, bolted onto a Celestron dovetail plate that in turn matches up with the saddle of the C-GEM. So that's a very easy connection there. I've got a Ultimate Power Box, Pegasus Astro Ultimate Power Box 2 attached on a plate to the handle. I think when I do this again, I'm going to move the Ultimate Power Box back so that it's more over the center of mass of the telescope body and imaging setup, and provide for a little easier balance than I have right here. I'm using a do not do strap up here, which is of course powered through the Ultimate Power Box, and the field flattener is the William Optics Flat 6A Model 3 that they recommend for this telescope. It's adjustable, which I cover in an earlier video. It does a great job, and it's easy to adjust and to flatten the field for your particular setup. Just behind the field flattener, I've got a ZWO off-axis guider, and I'm using a ZWO ASI 290 Mini for the guide camera. I've got a ZWO 8-position filter wheel, and I'm using the second generation narrowband and broadband filters produced by ZWO in that filter wheel. And then finally, my imaging camera is the ZWO ASI 1600mm Pro that I cooled down to minus 10 degrees C during imaging sessions. For software, I use Stellarium quite a bit for session planning. I generally shoot multiple targets on a given night, and Stellarium makes it very easy to bounce from one target, follow it up until it gets to the meridian or down close to the horizon, and then I can switch over, identify times when I need to switch over to a separate target. However, Stellarium doesn't have a full library of images, so I often will use the framing assistant in Nina to check or verify the orientation of the camera and the framing and the aim point for a given target, when Stellarium doesn't have that object in its picture database. And of course, to control the session, I use Nina, and PhD2 provides the guiding, and then all the post-processing is done with PixInsight. Now, one of the big draws of using Nina is the autofocus routine. And here's a result from one night, November 7th, it turns out. And this is all of the autofocus runs that were done in that one night. Now, Nina, one of the nice things I like about Nina, it saves the autofocus results off to a JSON, a JSON file, into a fairly obscure directory on your hard disk, so you'll have to find out where that is to see these files if you're interested. But it contains a lot of useful information, such as the temperature at the time that the focusing was done, the autofocus run was done, the time and date, and the filter type, and then the kind of method you're using to identify the optimum focus point. And then down here are all the measurement points. These are these plotting points that I've put here on a graph. So there'll be a file, each one of these lines, each one of these plotting symbol lines is basically contained in a file. And so each one of these will be multiple files produced through the night as you do autofocus runs. But you can see the focuser position and the half-flux radius value that it got for each focuser position. And then down here it'll tell you the optimum focus point and the optimum value of the half-flux radius. What I like to do is take those files from a given night, bring them out of the obscure directory into a directory where I do some post-processing, such as this right here. I just bring in each of those files, starting with the first one of the night and ending with the last one of the night, and plot up the points. I do a curve fit myself and determine what the fit parameters are, in other words, the optimum focus point and the optimum half-flux radius. And as you can see for this first curve of the night here with the HA filter at 19 degrees C, I got the same optimum focus point and slightly different, but not significantly different, optimum or minimum half-flux radius. And you can see that story basically unfolds for each of these more or less 6 to 7 different autofocus runs that were performed during the course of that one imaging night. And you can see some variability here. So as the temperature changes, and it doesn't change much here, it went from 19 degrees C when I started out to only 17 degrees C at the end of the next morning. And so that's just a 2 degrees C change, which is fairly mild for this time of year for us. But here you can see what happens is we start out with the focuser position out, and then as the temperature drops, the focus position and the focuser will tend to move in to maintain focus. You will also see some variability in the half-flux radius in terms of the low end versus the high end, and that's for two basic reasons. First of all, there's the what altitude are you performing the autofocus at? The closer to the horizon you are, the more atmospheric dispersion there is, and the half-flux radius will tend to be larger. Also, wavelength is a player here. The shorter wavelength color, blue 03, for example, should have a smaller half-flux radius than the red end of the spectrum with S2, HA, and red filters. So there is some tendency for variability in the half-flux radius based on altitude and based on filter, and then of course the actual optimum focus point will shift in based on temperature. But these are the results, and actually they're very consistent. You look at each one of these curves and my curve fit to the curves, all the points are following and fit the hyperbolic curve fit quite well. By and large, this is the story that I saw on each night of imaging with the GT81 and Nina. Nina did a great job of maintaining focus with the GT81 through all of the imaging sessions that I had. I never had any hiccups. There were never any issues at all. So that was a blessing for the first time to use autofocus throughout the night and maintain focus throughout the night without a problem. Now, even though you focus well, you can sometimes get some bad results, and here's my bad result. This is SH2-129, the Flying Bat Nebula with the Squid Nebula inside. I don't like this image. I'll let you know right now. I can't stand the image. I've processed it maybe 6 times, and I'm still, it gets a little bit better, I suppose, each time, but there are a number of problems. First of all, in the challenges category, this was my first target with the new scope and attaching my hardware to the scope, and also the first time using Nina. And as we know in astrophotography, too many firsts add up and you're looking at some bad results. I also found that I was shooting targets and running into a bright moon quite frequently during my imaging sessions with the GT81, and that proved to be a bit of a learning experience as well. Now, in the case of this particular nebula, the Squid Nebula is very, very faint. It's an O3 signal, but it's about the only O3 that's in the image, and it is quite faint. And I have an additional problem. The filters that the ZWO filters I'm using, they tend to generate quite a bright and broad star halo around bright stars. So trying to deal with those halos is somewhat problematic with those filters, and has been part of the problem with trying to pull out the Squid Nebula from the rest of the nebulosity. Now, in this case, the color space, I think oftentimes you'll see this shot with maybe with HOO, in other words, HA as the red filter and oxygen 3 as the green and the blue filters, leaving you with a red nebula and more of a teal colored Squid Nebula. And that's, I think the most frequent combination. There is some sulfur in the signal, though. There is some decent sulfur in this nebula. I did take data in the sulfur channel, so I didn't want to throw it out. What I ended up doing was combining 50% of the sulfur signal with 50% of the O3 signal to make a green channel, and then I just put the O3 in the blue channel and HA in the red channel, and that's why I'm tending to come up with more of a red-orange color for the nebulosity, and the squid tends to be more on the blue side than the teal side. Now the cons, well, basically I need more O3 data and I need a lot less moon, so I need to revisit this target next year when it comes back around, and probably toss these data out and just start over. The pros, well, I don't think there are any to this image. I'm not pleased with the image at all. I suppose from a scale of the image, the size of the image, it pairs well with the GT81. I think it's a good match. There is some actual nebulosity off to the on the top side of the photograph here, but the principal part of the nebulosity and the squid are well sized for this focal length and camera combination. So I suppose if there's a pro, that would be it. It fits well with this camera, but I need to do a much better job of collecting data and processing it. And I imagine I'll go back and reprocess the data yet again, trying to get a more acceptable image, but this isn't it. The next thing I tackled were a couple of galaxies. I was kind of doing these galaxies about the same time I was doing the flying bat. Again, I was dealing with a bright moon in the imaging session, so I did HA on this galaxy and the next one, and then when the flying bat nebula got past the horizon, I picked it up and followed it down for the rest of the night. This is the Triangulum galaxy. It's a good size target for this particular field of view. It is a difficult target in terms of trying to define the spiral arms. It's known as a flocculent spiral galaxy. It's not a grand design spiral galaxy like M51 where the arms are beautifully delineated. Here they're quite fluffy, and they don't lend themselves to easy identification in post-processing to pull out the individual spiral arms because they're not that well defined in this particular galaxy. It's almost like a fluff of blue and maybe some ridges in there, and that makes it a difficult target from the perspective of trying to pull detail out of it. I use the hydrogen alpha and red to make a combined red filter, and I use the HA and the luminance to make a combined luminance filter, and then I did some detail processing to the extent that there is detail with the HA and luminance channel, and did some color processing with the HA RGB data to improve color definition in the galaxy, and then brought them both together using LRGB combination. The technique I use for combining HA with the red and HA with the luminance is covered in probably the most recent video I have up, where I just revisited a technique that's been out there for a long time. Everybody's probably using it in one form or another, but anyway, that's the technique I use to combine the HA and red and HA and luminance. One of the challenges I had, one of the things I like to do is use StarNet++ to pull out the stars and then work on the nebulosity and then bring the stars back in. With this particular focal length and the nature of the HA in this particular target, I was finding that StarNet++ was also pulling out and identifying much of the HA knots as stars, and so that created a bit of a challenge in the post-processing as well. From a processing standpoint, I need to do a little better work in trying to pull out the spiral arms and to denoise the disk of the galaxy. The pros, I think I really do like adding the HA to this target because the HA tends to follow the spiral arms, and probably to the extent that you can perceive spiral arms in this structure, it's the HA that's probably doing that for you because it's tending to lie along those regions where the spiral arms are. So the HA does actually help. Adding HA to this target does actually help to identify where the spiral arms are, and it's one of the few galaxies out there that's probably appropriately sized for the GT81. It's not so big that it fills up the field of view as the next galaxy I'll show you will do, but it's not so small. It's just a little dot of blue in a vast star field. So here you actually see the galaxy, and you see that it in the context of surrounding stars. I also shot a lot of data with the Andromeda galaxy. I'm a little happier with this result. Obviously, this galaxy fills up the field of view with my camera and the 385 millimeter focal length of the GT81. The challenges with this target is pulling out the oval or the elliptical disk of the galaxy from the background space. It's a very faint disk, and so getting a good delineation of that is one of the challenges. The second challenge you often have in processing this galaxy is getting the blue in the spiral arms and the gold in the core of the galaxy, because it's just turned on its edge there, where it's quite difficult to pull out those getting those colors to jump out at you. M31 has quite a few and very detailed dust lanes. It's one of the most interesting features of the galaxy itself is the structure in the dust lanes, and pulling that out is one of the challenges of this galaxy. And I think the GT81 did a great job of this, along with the good focus, excellent focus provided by Nina. Color space, again, it's just like I did with the M33 Galaxy. I added HA, and you can see the HA here is these red knots and orange going around these dust lanes that you see here, including farther out here at the extent of the galaxy. So the HA really jumps out, and I think it adds quite a bit of interest to the photograph. The cons, I need to do a better job in defining the elliptical shape here. I've got some noise up here. The ellipse should run nicely around here and curve around. So I've got some noise here and noise up in here and some noise down in here that I'd like to get rid of. I was really impressed with the quality and intricate detail that the GT81 pulled out from these dust lanes. In fact, I can see dust lanes I don't even know that I knew were there before. With what the GT81 is pulling out. A lot of detail. With the size of the galaxy filling up this field of view, it really does make maximum use of each pixel in the ASI 1600 with this field of view and this target. So I'm pretty pleased with that, and I think the HA adds quite a bit of interest. Then I moved over to the California Nebula, and this is where I ran smack dab into a bright moon. Once the moon got past this target, I came back to it and finished it up. The challenge with this target, the California Nebula SH2-220, is that there's very little oxygen-3. In fact, if you take a few subs of this target, you might convince yourself there's no O3 data in this image at all. And it's there, it's just very faint. Another thing you'll have to be careful of, you may have to play with the orientation of the camera in order to get the nebula to be across the diagonal so you can fit it into the field of view. Processing here is just a standard SHO color combination, and there's just very little O3 that I think most people probably just skip it and shoot S2 and HA. In that case, the nebula is going to be more confined. You won't see this wispy bit stuff here. You're going to get a more confined, more red image than you're seeing here. I'm pretty pleased with how this image came out after all, even though I had my doubts when I was collecting what seemed to be no O3 data whatsoever. The Sol Nebula is the next one on the list here. It's SH2-199. There's no challenges with collecting data for this image. It's good data on all narrowband channels, and the object fits quite easily in this field of view, so there's no challenges in collecting data for this target. Again, this is a standard SHO Hubble palette combination of colors. There are some nice cloud structures that are brought out and delineated by using the SHO combination. I'll probably do more to bring out the transition from the cyan into the orange and see if I can't bring out more of the detail here. It processed very easily because you have great data in the HA, O3, and S2, so it's very easy to process. The final target I shot is one that I had not intended to shoot with the GT81 because I knew it wasn't going to fully fit in the field of view of my camera and the GT81. But at the time I was shooting the California Nebula and running into the moon, so I needed to do something with my imaging time. And so I picked a target that was as far away from the moon as I can get, and this is it. So this is SH2-131, the Elephant's Trunk Nebula. The Elephant Trunk is here, and I have shot this before, but using my 700 millimeter telescope, was just basically focused on the elephant trunk, and I didn't get any of this nebulosity that's around here. It's really a very interesting target with tons of detail in the broader nebulous region of the target. There are no real challenges in terms of that because you get such great data in all three channels. And again, this is another Hubble palette image. Well, it doesn't quite fit into the field of view, but that's just the way it is, and that's not the worst thing. It fits well enough that you get a good sense of most of the context of this nebulous region. And the pros, well, there's great signal strength in all three channels, very easy to process, and there's just tons of detail in the cloud structure here that the GT81 is pulling out. I'm very pleased, as you might have guessed, with the William Optics GT81 Model 4. It worked like a charm. I had no issues. The image quality is great, but of course you got to tip a hat to Nina and the autofocus routine in Nina, because you can have the best optics in the world, but if you're not focused, it don't matter. I had no issues with using Nina, and it worked flawlessly throughout each night of imaging, maintaining excellent focus. The focus of movement is going to be inward as the temperature drops with this telescope, and the half flux radius is going to be between about 1.7 and 2.5, depending on how much atmosphere you're looking through and which filter you're using. At 385 millimeter focal length, that is with the telescope and the field flattener, combined with my ASI 1600, it's a very useful field of view. I think there's quite a few DSOs that you can find that fit quite comfortably, and even maybe not as comfortably, but you get most of the DSO in the imaging field of view. So it's actually a very useful combination with the fairly short focal length that's quite tolerant of guiding mistakes and guiding errors. So if you have a mount that's not as well behaved as others, it's quite tolerant of that. So it's a very user-friendly scope. All in all, though, my first use findings with the William Optics GT81 is that it's an excellent telescope. I love the image quality. It's from just a size perspective and handling, it's quite light and easy to carry in and out, which is something I do every morning and every evening when I'm out imaging. The build quality is excellent, of course. This is typical of William Optics gear, but the image quality I'm very pleased with, and I think some of these targets more than others, but a few of them really brought that out in these first imaging results with the telescope, and I'm looking forward to get back to using this telescope when some of these nebulous targets return. Well, I'm going to leave you with the images I took with the GT81 and clear skies. I'll talk to you guys later. Thanks for hanging in there.